in equipment and makes the underlying equipment transparent to upper level functions, upper level applications. So the Linux that you are running through virtualization, you are running on top of your Microsoft. That Linux is able to run your simulator. Now your simulator is going to access the processor, the processing, and the memory resources as if that computer was originally Linux. And this is what we are saying. It shields the differences equipment and makes underlying equipment transparent to upper level applications. So that simulator is an upper level application. So to that simulator, it's working in a Linux environment, and yet it is not. So it reduces the degree of coupling between resource users and resource entities so that users no longer depend on specific types of resources. So virtualization does what is called decoupling. Decoupling means it's not tying a particular application to a particular hardware. Now, because if applications are tied to hardware, then it means that application cannot be used by any other application. Now, what the decoupling means is that that application will only access that resource during the time it's operational. The moment it finishes executing, it delinks itself from that resource so that that resource can be used by other applications that are sharing it. So this is virtualization technology in general, but now we have virtualization technology in cloud computing. Now, because we said in a cloud, we have networking, we have storage, and so on, and different operating systems. So in cloud computing, it's a higher level of virtualization after development. So the virtualization technology is a crucial driving force for cloud platforms. It is a crucial component of cloud computing, but cloud computing is not limited to virtualization. Now, this is important because some people were equating cloud computing to virtualization. So they were saying that, they were saying that cloud computing and virtualization are the same thing. That is not the case. In cloud computing, we go a step further. In addition to virtualization, we have what is called on-demand supply. In other words, services are availed to you as you demand those services. I gave you an example of graphical. Most times you don't draw. Most times when you're writing your documents, you hardly ever draw. Now, graphical software for graphics is quite expensive. So it doesn't make sense to buy that software and you're only going to use it once in a while, or maybe you are only going to use it one-off. Something like simulation software, you are not going to use it every day. You'll only use it when you are doing your research. So on-demand supply, in cloud computing, there's on-demand supply, meaning you will look for a certain service when you need it, and then you will pay for it for the time you are using it. So instead of buying that software and loading it onto your computer, and you only use it once, you buy the services of that software. And so you pay it, you pay on a per use basis. So on top of virtualization, cloud computing includes on-demand supply. It includes billing, what I've said. You request for graphical services, and you pay for them. Where payment, there's usually a payment model where you may pay for a period. Let's say you may pay for 6 months. You may pay for hours and so on. That depends on the billing model. Cloud computing also includes technical characteristics such as flexibility, transparency, and building blocks. So do not equate cloud computing to virtualization. But virtualization is just one of the aspects of cloud computing. So all resources are connected, managed, and scheduled by the cloud platform. The resources that we are talking about include computing, storage, applications, and network equipment. So through the virtualization technology, the cloud platform can uniformly manage diverse resources at the bottom. Now, the resources at the bottom include the hardware. In other words, the servers, the networks, the operating systems, and so on. So uniformly manage the diverse resources at the bottom. It manages resource scheduling at any time and realizes on-demand allocation of resources so that a large number of physically distributed computed resources can be logically controlled. So you may find that these resources are in different geographical locations, but you can manage them logically. Now, logically means that you have a console and you have a management application. So you shall use this management application to manage resources which are geographically dispersed. So that is about virtualization. I will revisit virtualization later on. So is there any question so far? Right, so we go to the next one. The next cloud enabling technology is the web technology. So cloud computing has a deep-rooted dependence on the internet and the web. Now, remember, the internet is a network of networks. Now, a network is an interconnection of computers. A network is an interconnection of computers. But the internet is an interconnection of the different networks. Now, the internet was designed for something. The internet was designed for the transfer of documents. And the linking of documents. So the web is a network of documents. I mean, as envisaged initially, it is a network of documents. We have said a network is an interconnection of computers. An internet is an interconnection of networks. A web is an interconnection of documents initially. But these days, when we talk about web, we talk of an interconnection of resources rather than an interconnection of documents. So since earlier on we talked about the internet, we shall not talk about this because that was the first thing, the first technology we talked about when we started talking about cloud computing. So we shall talk about web technologies. So web technologies is often used as the realization medium and management interface of cloud services. Now, what does that mean? We use the web to access resources in the cloud. And we also use the web, in other words, our interface is that interface of the web. So we can also use it to manage resources. So we use it to access resources and we use it to manage resources. So we have two types of web technology. We have what is called the basic web technology, and we have what is called the web application. So the basic web technology and then the web application. So we have the basic web technology where we have the World Wide Web. Now, said initially, the World Wide Web was an interconnection of documents. But with the internet, it is not an interconnection of documents, but an interconnection of resources. So the World Wide Web has nowadays become a system of interconnected IT resources through the internet. Its two fundamental components are the web browser client and then the web server. Now, the web browser client is what the user uses to access resources. That is the client. This is where the user interacts with the cloud. And then the web server is where we keep our resources. So this is the user. The web server most of the time is run and maintained by the cloud service provider. Our web application features such as scalability and security are improved by other components such as proxies, caching services, gateways, and load balancing. So a web application is any application that you want to run on the web. So these additional components are located in the hierarchy between the client and the server. Things like proxies, caching services, gateways, and load balancing happen because most of the time, the web client uses the network to access the web server. And it does this by sending requests, and it receives responses. A web client usually sends requests to the web server. Now, the web server processes those requests and sends the results of the processing. So, but in between, we shall have proxies. Proxies are things that you send to do something for you. Caching services where you have temporary storage, and gateways which allow you to access different clouds. And then load balancing where tasks are distributed evenly. So between the client and the web server, we have these things. So web technology architecture consists of three basic things. Now, I'll not go into the details of this. I'm sure you must have met them somewhere along the line. And these are terms that you know. We have the uniform resource locator, which is a standard syntax used to point to web resources. Identifier. URLs usually consist of logical network locations. So URLs is a standard syntax. And most of the time, the URLs are written in human readable form. Like when I say .ac.ke, you'll understand academic Kenya. uonbi.ac.ke. University of Nairobi, which is an academic institution that is based in Kenya. Now, that URL basically is tied to yeah, is tied to an IP address. So it's easier for you to inter to under to interpret and understand what uonbi.ac.k is. It's much easier than for you to try and remember 192.168.2.1. So there is a syntax for conversion of IP addresses into URLs, which makes some sense to you. Then we have HTTP, Hypertext Transfer Protocol, the basic communication protocol for exchanging content and data through the World Wide Web. Usually, the URL is transmitted via HTTP. So HTTP is a transfer protocol. Transfer protocol in the sense that it is a standard for allowing you to transfer information. Then we have what is called the markup language, which provides a lightweight method to represent web-centric data and metadata. So web-centric is the data that you send across the web. So remember, initially, the web was created for scientists, and it was usually text-based. So the markup language is a lightweight method. In other words, we use a standard method for writing documents. Now, so presently, HTML is commonly used in web pages, and the meaning of the tags is fixed. Now, in a hypertext markup language, for you to write a web page, you have to learn HTML. Now, where HTML, the meaning of the text that you use is fixed. It doesn't change. Now, you have to learn it just the way you learn a programming language. Like in C, semicolon has a meaning, quotation marks have a meaning, and so on. So in HTML, for you to write a web page, you have to learn it. So the meaning of the tags is fixed. But later on, what happened is that this had its complications. For you to do anything, you had to learn the HTML. And then what it meant is that there are certain things you could not represent in HTML. So later on, there came what is called the extensible markup language, or XML, where you define the tags. So the user can freely assign meaning to the web data through metadata. Now, I talked about a markup language which provides a lightweight method to represent web-centric data and metadata. Metadata simply means data about data. So for any data that you define, you must have information about that data. So metadata means data about data. So web applications. So here we've been talking about the web technology architecture. Now, web applications. So these are distributed applications based on web technology, usually display the user interface through a web browser. Due to their high accessibility, these applications appear in all types of cloud-based environment. A typical web application may have a three-tier model as shown in the table and figure. So it has a expression layer. Now the user accesses the web application via a web interface. So that web interface for a web application, we refer to it, appears at the expression layer. So the first layer, which is used to represent the user interface. Then we have the application layer, the second layer, which is used to implement the application logic, because an application is doing something for you. So an application is basically a series of instructions. Now, these instructions have logic. The logic may include it repeating, it sending out an output, it receiving an input, and so on. That is what we refer to as the application logic. Then the data layer, the third layer, which consists of persistent data storage. This pattern is also commonly referred to as the model view controller. So the data layer, because an application is simply logic, the data layer is you are sending data which is going to go through this logic to do something for you. So once it goes through the logic, it produces an output. Now that output may come to you, or that output may be stored somewhere. So that is under the data layer. So the pattern is often referred to as the model view controller or the MVC pattern. Three model of the web application. Now, remember that anytime we talk about layers, we are talking about rules. So there are certain rules and standards that apply to the data layer, to the application layer, and to the expression layer. So the expression layer will appear both in the client, which is your web browser, and it will part of it will appear on the server side. But the application layer and the data layer, the application layer, the web server will be governed by rules, some rules in the expression layer and some rules in the application layer. And the data storage server is going to be governed by rules in the data layer. So the server, we have the web server or application server, and again we have the data storage server on the server side of the web application. So what is the MVC pattern model? It's part of the application used to process the data logic of the application. Model objects are responsible for accessing data, data in the database. This corresponds to the data layer. So the core device is a data storage server or a database server. The view is part of the application that handles the display of the data. So usually views are created based on model data. This corresponds to the presentation layer. The presentation layer or the expression layer. So for a web application, the browser on the client side is used for requesting and displaying web data. So you send a request through an interface on your client side. Now that request is sent to the server. Now in the server, we have the logic. So based on the request, the logic is kicked into motion. Now, after it's performed its processing, it gives an output, and that output again appears on the client side. So this web server on the server side processes the browser's request and returns the requested web page corresponding to a static website, and the results of program execution corresponding to dynamic web pages. Now, I'm sure you know the difference between a static web page and a dynamic web page. Static You send for a web page, it displays. Dynamic, you may send a request. The web page asks you for additional information. You put there the additional information, and the process goes on until what the service that you wanted is fully completed. Then the controller is a part of the application that handles user interaction. It reads data from the view, controlling user input, and sending data to the model. So corresponding to the application layer, it mainly deals with transaction logic, and the core device is the application server. So the MVC model helps to manage complex application, simplifies group development, makes application testing easier. Okay, any question on the web applications? Any question? Okay. Next is the multi-tenant technology. So multi-tenant technology makes it possible for multiple users. In cloud computing jargon, these users are referred to as tenants. Now, I must have mentioned to you earlier on that sometimes when you are reading technology, when you are studying technology, it appears complex. And the reason it appears complex is that sometimes we do not interpret the English. So we know that multi is many. Tenant is people who want to use a certain thing. So in cloud computing jargon, tenants are users. So multi-tenant applications make it possible for multiple users to logically access the same application simultaneously. So each user has his view. So it's one application, but you'll find that many users can access that application. Now, those many users are not aware of each other. And those users, and basically it's also using virtualization. So the original application remains intact. But if 10 users want to use that application, these 10 users will get copies of that application. So they do not directly interact with the application, but they interact with copies of the application. So each user has his own view of that application. He may change the interface. He may remove some things. He may add some things to that original. So each user has his view of the application that he uses, manages, and customizes, corresponding to a specific instance of the application. So notice here we are talking about specific. So an instance is a copy of that application. Each tenant will not realize that other tenants are using the application. This ensures that each tenant will not access data and configuration information that is not their own. That is what I said. The original application remains intact, but copies are made as requests are made. And for it, you can do anything you want with your copy. You can configure it the way you want. Your copy is only one which will access your data. Your copy will not access another user's data. So each tenant can independently customize its application features according to the user interface. Tenants can define application interfaces with special interface appearances, business processes. When implementing applications, tenants can customize the rules, logic, and workflow of the business processing. So they can change the logic of the processing. The data model, tenants can extend the application data model to include, exclude, or rename fields of the application data structure and access control. Tenants can independently control the access rates of groups of users or groups. Multi-tenant application architecture is usually more complicated than single-tenant application architecture. It's because it needs to support multi-user sharing of various components. So many users need the sharing of these 5 components: the entrance, how you start using the application, the data model, what data is this application using, the middleware. Remember, applications need an operating system to run. But you see, in the original computer, the operating system coupled an application to resources. So in the old systems without virtualization, what happened is that once an application started using a resource, it meant that that resource was tied. And that is what we are calling tight coupling. But now when we use middleware, middleware is one which creates copies or instances of resources. So instead of directly accessing those resources, you access copies of those resources via the middleware. Then database. Each user or each instance of a user has his own space on the database. And that's why we say you cannot access another user's data. Then to maintain a security level, to isolate different tenants' operating environments. We don't want you accessing other tenants' data. Because if you are able to access other tenants' data, you will modify them. You'll modify them. And when the other user comes to use his data, he finds that his application is not operating the way it's supposed to operate. So the general characteristics of multi-tenant applications are as follows. One, they have user isolation. In which case, I mean, that's just an English term. The usage behavior of a tenant will not affect the availability and the performance of the application to other tenants. Because remember, the original application is unaffected. Data security, tenants cannot visit data of other tenants. Recovery, data backup and recovery processes are operated separately for each tenant. So they cannot, I mean, it cannot be uniformly done because different tenants have different data. They are working on it at different times and so on. So they should not be tight. They should be as loosely coupled as possible. Scalability, the application can be expanded according to the increase in the use demand of existing tenants or the increase in the number of tenants. So because these are copies, as the tenants increase, the number of copies that are made increases. And this is what we are calling scalability. Measured usage, charged based on the application processing and functions actually used by the tenant. These are 10 different people using this application for different functions for different times. So they should be charged differently. So you are charged per use. And then data tier isolations. Tenants have different independent databases, tables, and schemas that are isolated from other tenants. They can also be specially designed for multi-tenant shared databases, tables, and schemas. So that is multi-tenant. So that's another aspect of cloud computing. Okay, so is there any question? Any question? So I think we have only 2 minutes. I'm sure in the next 30 minutes you'll be having another lecture. So we shall stop there for today. Again, the attendance is very poor. I don't know for what reason. But anyway, so let's stop there. We shall continue tomorrow.